Hello everyone, hopefully you are able to hear me. Is my voice, can you hear me?
Yes.
Okay, nice. So today we are going to start writing Sql queries directly and we have our lab handout for this lab, and in this document we included a ODB file as well. If you would like to follow along, you might download it. And in this database, actually we have 3 tables. It's a simple one. We store a bunch of companies. So for each company we have a company name and companies have monthly payments. We have a user table. We keep the name, surname of each user. We also keep a credit. So this is like the money of the user. We have some status showing the subscription level of these users. We have date of birth and the cities that these users living in. And for each of these tables, we have just one primary key, which is the ID. It's the same for the company as well. And in the partner of table, this is a relation. We relate one user with company. So this is a many-to-many relationship, meaning that one user could be the partner of many companies, and in a company there could be multiple users that are the partners of these companies. And I will also show you quickly under tools and relationships. This is the relationship that we defined in this database. So the parent side is user in this link, and the partner of is the child table. You can also check it if you double click on this link. The user is the parent side. We enabled the update and update and delete cascade options, so that whenever we update the ID of some user, if that user is also included in the partner of table, it will be automatically updated. Or whenever we delete some user, for example, the user with ID number 5, it will be deleted in the related table as well. From the company side, company is the parent, and while we were creating these links, we started from the parent's foreign key and we dragged it to the related attribute inside the child part. So today we are going to start writing some Sql queries, but to remember, one option was to go through queries, and then we have create query in design view. If you go through this option, you have the option to add a bunch of tables, and if those tables are related, it will make the join operation automatically. But for now, let's just get the user table, for example. I will close this new window, and in here we have a bunch of columns, and for these columns we are making projection. For example, we can say, okay, I would like to project the ID of the users, and let's say also the name of the users. And for some of these columns, for example, if I choose the status, I may make it invisible and put some criterion for the results of this column. For example, if I write half in here, and by the way, the attributes are the ones that are text are case sensitive, so upper and lower case letters will differ. So if I run such query, now I will see the users, but I'm making a selection saying that the status of these users should be equal to half. So this was something that we did earlier, and we were able to save these queries. Let's keep it as query number 1. And if I close it, my query is saved here. Whenever I double click on it, it will run the query and display me the results. And if I would like to go back into editing that query, I have the option to go back to edit. This is going to use the design view, but some sneak peek that we did in the last lab was that for such queries, we can also edit in SQL view. And if you were to choose that, you see the SQL code that corresponds to this query. And for some basic queries, we can use the either option. We can design it in the design view, or we can just directly write it in SQL. But for some more complicated ones, that we need to write it as in SQL. So otherwise, making or using the design view makes our lives harder in such cases. So therefore, we are going to use SQL queries in this lab. As I said, if you would like to follow along, you might download this database using LibreOffice. So there is actually, so let me just get rid of these other tables. So there's actually two ways of creating a new SQL query in Base. So one option is under Queries and Create Query in SQL view. If you click here, you have the option to directly write your SQL query. So for example, let's say that we would like to find the name and credit of the users that have at least 400 credits. So with the SQL, we have a bunch of keywords. So select is one of them. We can project a bunch of attributes from some tables. This is going to be the most basic form of an SQL query. And in the class, you just directly write the attribute names and table names. But in Base, we have to say that something is a table or an attribute, we need to use the double quotation marks. So for example, if I would like to use the user table, if I'm projecting something from the user table, I write user, this is my table's name, but I need to include these double quotations. So this is something specific for this software. In some other software, they might use other forms of showing it. But in Base, we need to include these double quotations. In the exams, quizzes, you don't have to. So you can just write user in the exam or in the quizzes. But in Base, we have to put the double quotations to say that something is a table, or also in the attributes case, we need to include this double quotation. So name is an attribute in the user table. I'm including these double quotations to indicate that. Otherwise, it doesn't know that whether this is some table attribute or is it going to be used as a value, etc. So we would like to project the name and credit, so I can write such query. If I just run this query, it will display me the results of this projection without any criteria. So I would like to also specify some criteria, saying that where I want the credit to be larger than some value. Actually, it was saying that at least 400 credits, so I need to include this larger than or equal to sign, and this is going to be my value directly. And the keywords that we are writing with all uppercase letters is just some convention. I can also write it with small letters, and to be able to easily see my query, I include these keywords on new lines, but I don't have to do that as well. So some of the things that we are doing here are conventions to make our query more visible. And in standard SQL queries, at the end you put a semicolon, but again based on some of the implementations of the software, so right now we can go without the semicolon, but in some cases we will need it, so I will be putting it, but I don't think it saves the semicolon at the end, it automatically puts it, so we can also go with this. So this is our query. We are making some selection for the credit, and if I run this query, now it will display me the results of this query. So I guess you also saw such things in the lecture, and this one should be simple enough. This is one way of writing SQL queries. Again, we can save this query as query number 2, for example, you can double click on it to show the results when we run it. We can edit back it in the SQL view, so you might realize that I was putting these on new lines, but when I saved it, it keeps it in this form. And you can also, for this query, go into the edit mode in design view. So these are convertible. So whatever you do in the design view, you can see it in the SQL form and vice versa. The other way of running SQL queries is when you go through tools under SQL, you have this execute SQL statement window. And for example, let me write this same query here, select name and credits from the user table with the condition saying that where credit is larger than or equal to 400. So again, in here as well, I can use my keywords on new lines. So for select queries, we have the show output of select statements option here. So if the query is going to show some results, because some queries are select queries, they are designed to show us some results. But with some queries, we make updates on our database, we insert something or delete something. For such queries, we don't need to show the output. But this is a selection query, I need to show the output, otherwise why am I running this? So I need to enable this show output of select statements, and then if I click on execute, it will run this query and show me the results. In here, it is not that good looking. The other form was better for select queries. But one difference is that in execute SQL statement, in this window, we can run any kind of query. So select queries are okay here. Insert, update, delete queries or create queries are runnable in this window. But if we look at the other one, for this one we can only write select queries. So using this, we can only run select queries. For our other queries, right now we are going to use this execute SQL statement window to run them. But in the upcoming labs, when, for example, we are going to create some forms, we are going to include buttons, and whenever we click on that button, it will run some query. To do that, we are going to use Visual Basic, and we are going to store our queries in that part. So for now, this is more like a testing part. So with execute SQL statement, you run the query directly, you test it, you see some results, or for example, you might need to update something in your database, and with some query, you can directly do that. So for now, first, we are going to use this option. So we are going to, so let me go through queries, create query in SQL. But this is only usable for select queries, remember that. When we go into other kinds of queries, we are going to switch back to execute SQL statement window. So in the handout as well, we have a bunch of queries, and we would like to do them using SQL. The second is saying that find name and date of birth of the users born between two different dates. So we would like to first start with what we want to project. So it is going to be the name and also the date of birth of users. By the way, while you are writing the table names or the attribute names, you need to be careful. So this should be exactly the one that is included in the table. For example, the column name is exactly a name. If I write something else, if I have some typo, it doesn't know what this should be, and it will give us an error in that case. Let's also see it. So for example, if I'm projecting the name and date of birth from the user table, if I run this query, these are my results. But let's say I made a typo, user, if I run this query, now it will say that table not found in statement. So in this statement, I include some table name, but this cannot be loaded, this cannot be found because I made a typo. So let's check whether this is case sensitive or not. So again, with the name column, the N letter was capital in the original, and if I include a small case letter, again it cannot find the attribute this time. So we would like to only show the users that are born between 1990 and 2000. So to do that, we can add a var condition, right? We can say var date of birth is larger than some date, and with date type we have a special way of writing it. Remember, with text we were using single quotation marks. With date as well we need to use the single quotation, and while writing the date you should follow this format. So it should be year followed by the month and the day, and in between these numbers you need to include the dashes. So for year, now I should start with 1990 because I want the ones that are born after this date. So the first month, first day, and so this is the logical AND operation. I would like to put some additional criteria. Now I want the date of birth to be less than or equal to. So if it is shown as green, you might understand that we forgot to include the double quotations. So with the attribute names and with the table names, they should appear orange. So this time it will be 200101. So if I run this query now, I don't need to save it, I just want to run it. So we made something wrong. It says that column not found. Again, for I guess date of birth, we wrote data of birth. So if I run this query now, it displays the results, and if I were to check each of these date of births, they are in between the given dates. So this is one way of finding something in between. So we include the attribute twice with an AND operation, and we specify the lower and higher bounds. But another thing that we can use is, after writing the attribute names, we have this between keyword. Then after writing between, I don't need to specify this larger than or greater than signs. And since this is for the attribute date of birth only, I don't need to write it twice, and I don't need to write AND, because the between operator, oh sorry, for the AND I need to write it, okay. So the between operator looks at this attribute and keeps it in between these two values separated by the keyword AND. Any questions, problems so far? So if I run this query, the results are the same actually. So between is some keyword that we can use if we are looking at something to be in between two different things. So the third question says that, let me maybe open a new query for that. Find name, surname and city of the users that live in either Ankara, Istanbul or Izmir. So again, we are interested in the user table only. So we can start by specifying that. And we would like to project at the end the name, the surname and the city. So city is another attribute of the user table. And we have a condition on city saying that the city should be either Ankara, Istanbul or Izmir. One thing we can do is writing like Ankara, since these are strings, these are text, I need to include them in single quotation this time. So with table names and attributes double quotation, with date and with text, single quotation. I can say or the city is going to be Istanbul, or it is going to be Izmir. So there is nothing wrong with this. I can run this query and display the results. But let's say that we are given a list of lots of cities. In this case, writing these ors, writing the attribute name again and again could be hard. So instead we have the operation in, and then we define a set of things. So a set of things is represented with the parentheses. So in between parentheses I can put Ankara, also Istanbul, separated with commas, and Izmir. So if you put your values in between the parentheses, it is going to be a set of values. And if I say in, it is going to say that, okay, the attribute city should be in this set of things. The set of things could be like set of text, it could be a set of numbers. So since these are text, I include the single quotations with each of them. But if this was numbers, for example, then I can just directly write those numbers separated by commas. So if I run this query again, the results will be the same. So these two queries are equivalent, but this is easier to write it. Let's do another one. So this time we would like to find name and surname of the users without a city record. So sometimes in your database, some attributes could allow null values. And in this case, we are allowing null values for city. Actually, other than the primary key in these tables, we allow null values for all of the attributes. So we would like to this time find the name, surname, and city of the users. It is going to be from the user table, and our condition saying that city should be null. So we can write is null. This is another keyword. If the city is null, it will show up in the results. If I run this query, now it is showing me the users. If I want to check in the user table, William has no city, Floyd has no city, and Scott has no city record, and these are the ones that are returned for such query. It is also possible to say that is not null, then the values that we get are going to have non-empty cities for all of them. Now for the other one, it is saying that find name, surname, and credits of the users whose names start with the letter W or whose surname include the letter O. So let's go through this query and edit it. So I can also close this results, or is it for closing the query? No, let me not risk it. So we would like to project the name, surname, and this time the credits of some users. And for those users, we have two conditions with the OR operation. It is saying that either the name starts with the letter W. So my first condition, I want the name to start with W, and from the last lab you should remember that we were using regular expressions, so some string that includes some letters and special characters. For example, the star was meaning that any number of any character could replace this, or the question mark was meaning that one of any character could replace the symbol. In this case, we want the name to start with the W followed by anything, any number of any character. And to use regular expressions, our keyword was like. So instead of writing equals, if this was some exact string like Ali, I can use the equals sign to search it. Again, I can also use the keyword like. But if this is including regular expressions, I need to write like. otherwise it is not using the regular expressions. So this is one condition. Or I want the surname to include the letter O, and it says that whether capital or small. If I check the user table in edit, I will see that the name is using the data type text, and this is the case sensitive one. So the uppercase and small case letters are different. It is not the ignore case version. Therefore, in such case, coming back to our query, so for surname, when we say that it should include the letter O at any position, it could be in the beginning, in the middle, or at the end. And for the ones that are for the ones that are not the first letter, we are going to use the small case O. So I'm going to write like in between double quotations, since this is my text. There could be any number of any characters at the beginning, followed by some O at any position, and then I have any number of any characters following. And then
tell me the meaning of stars again.
The star means that in our text, the text that we are searching, this star can be replaced by any number of any character. So for example, for this one, we can have just one O. We can have like a bunch of characters followed by an O. And it can have any characters O followed by any number of any character as well. So we can have two O's as well. So this is any character in this case and followed by an O character. Is it clear?
Yes.
Okay, no problem. And with the question mark, it is specifying how many of these characters could replace. So if I write 2 stars, for example, it doesn't change anything. But with the question mark, for example, if I have the question mark there, then it should be exactly one character. So B-O, R-O, these are fine for this. But if it is like B-B-O, then this is not fine, because before O there are 2 characters, but we allow only 1. So since we are searching something inside the text, we are using the small case O with star symbols at the beginning and at the end. And it can be also, if it is the first letter of the surname, it could be the uppercase O followed by any number of any characters. Or if we are allowing O to be at any, or let me say it like this. So in this data set, we know that the surnames are starting with the uppercase letter followed by small case letters. But in some case, if we were to have some problems, etc., with capital letters, for example, then we can also check the capital letters in the positions that are not the first position. So therefore, it might be a good idea to also include a star here. So we are searching for small O at any position, and we are also searching for capital O at any position. So this is our query in this case, and if I run this, now I'm displaying the users. For some of them, they are here because of the first condition. The name includes the letter W. And for some of the users, they are here because they include a letter O in their surname. And for some of them, it could be the both. For example, for Wayne, it has the W in name and it has the letter O in the surname. So both conditions are satisfied since we are using the logical operation OR. Whenever one of these conditions are satisfied, we return that data.
May I ask something? If we would like to get the names with the third character is O.
So in that case,
like third, but
in that case, what you need is like 2 question marks followed by an O. And if you would like to allow any number of other characters followed by, you can include the star. So for this one, it could be like BBO, BBO followed by anything else. So then you are searching for a letter O in the third position. But if you don't include the star, then this is going to look for names with 3 letters, and the third character is going to be O. Any problems? Other questions? So with the other question, we would like to find all distinct cities that users live in. For example, if I have such query saying that, okay, from the user table display the cities, if I run this query now, these are the cities that users are living in. But some of the cities, so in some cities there are multiple users, and those cities I see it multiple times. For example, for Istanbul I have multiple instances, and sometimes I would like to see only the distinct ones. So for that we have the keyword distinct. So if I write select distinct city from the user table, it will look at the city table, the user table for the attribute city, and it will only project the distinct ones, only the unique ones. So if I run this now, for some users we have null city, it is also included here, and for the other ones it is listed in a sorted manner. So these are the cities that our users live in. Any problems, questions so far? So we also have some functions that we can use in our queries. And whenever we are using the result of a function, we would like to project it. So for example, let's say that I would like to find the highest credit of the users. It's going to be from the user table, and the function is included directly, and functions get parameters. So in between these parentheses I give the parameter to the function, and for the function max it finds the maximum value of the given attribute. So remember, for attributes we were using the double quotation marks. So for the credits attribute, find the maximum amount from the user table. This is what this query means. And whenever I run this, I will see just one value. So with our usual select queries, we were displaying a bunch of results, a set of results, but the results of functions are a single value, and we are seeing this single value here. And I can also give different name for this column. For example, with the functions, the names are not that good looking, and if I write as, find this value and project it as with some name. So I can write the maximum, for example, for this one, and when I run this query, now the column says maximum, and if I were to use it as an attribute at some other position, its name will be maximum as well. So with functions, if I don't give the name, it is maybe hard to remember, and if I give the name, it will be easier for me to remember the name and to use it somewhere else. And whenever we have such notation, you might also think that, okay, finding the max, this is going to find me the max, and if I were to find the user with the highest credit, for example, can I write such condition saying that, okay, find the name and credit of the users where credit is equal to the maximum credit? But with functions, this is not possible. If you write it like that, it will give you an error. It says that this is not a condition in the statement. So for functions directly, I cannot use them as direct conditions. If I would like to find the user with the highest credit, then I need to use subqueries for it. So a subquery is any query that I include in between these parentheses. For example, let's say that I somehow have this maximum value. Then I would be able to write this, right? Whenever the credit is maximum, for example, the maximum value is 1050. If I run this query, this is possible. And I would like to replace this maximum value with a subquery, so as any subquery. And the subquery that we just wrote is actually, we can write it here. So remember, we wrote there maximum of the credit from the user table. So this is exactly what we just wrote. So let me fix it quickly. It should be like that. So without these parentheses, this is exactly what we wrote in the beginning. And I would like to use this result as a subquery. So instead of writing the value directly, I would like to write this subquery. So subquery is any query that I include in between parentheses. Whenever I run this subquery by itself, so for example, let me quickly grab it and create some other query. If I were to run it, it displays me the result. So it is working. So I can use this working query as a subquery, and whenever I run it, it will display me this result. And with functions, we also have the minimum, for example. If I write minimum here, if I run it, it will this time display the one with the minimum credit. But one thing is, if we are saying that it is directly equal to, exactly equal to, then we should make sure that whatever we wrote here returns just one value, because we are looking for it to be equal to one value. If this was actually showing multiple things, then we cannot use the equals sign. So for example, to show it, so this is showing just one value. But if I were to write, this is not that meaningful, but as an example, if I were to just get the credits from the user table, it returns a set of results. And therefore, if I were to use it as a subquery, it will not function with the equals sign. If I try to run it, now it says that single value expected in this statement. So whatever I wrote in this subquery, since I'm using the equals sign, it should be just one single value, but it is returning multiple things. If it is returning multiple things, then I need to use the keyword in, because this is a set of values. And if I use it, it displays me the results, but these are not, this query is not that meaningful, because we select all the credits from the user table and we then display the name and credit of the users whenever we have a credit with the same value for one of these results. It's not that meaningful, but for the sake of example, we did it. So returning back to this form, so this was finding the maximum one. We can, for example, write, let's find the average credit and then find the users that are paid higher than the average credit, for example. So whenever we use this query, they are all larger than the average credit. Or we can say that, okay, let's make it less than the average credit, and these are the users that are paid less than the average credit. Any problems, questions with this one? So the important thing is that if we are going to use the result of a function, we need to include it, or let me say it like this. If we are going to use the result of a function for a where condition, then we need to include it as a subquery. Otherwise, if I directly write the function, it's not possible to use it like this. So it gives us an error in this case. And it says that not a condition in the statement, so I cannot use this function directly. So some other query, or to see some of the other functions, there is also the count function. Let's find the number of users, for example. Then I can say count with some parameter, and this parameter is which attribute we are looking at when we are counting our entries. If we would like to say that, okay, any attribute is fine, just look at the entries as a whole, then we can use this star symbol, and we can say from the user table and run it, and it will show us the 20. So if I look at the user table, there are 20 records in this table when we look at the entries as a whole. But one other option is to count based on some attribute only. For example, for the city, some of the records have no city. These are null values. And if I were to count based on, so this is the one that we are not using, this is the one that we are using. So if I were to write city for the parameter of the count, then it will just look at the city attribute. And this time, 3 of the users have no city record, so therefore we see the count as 17. So most of the time these functions will be enough for us. So we have average, minimum, maximum, we have count, and we also have sum. To sum up the values, let's also quickly see that. We can, of course, only make these minimum, maximum, sum functions on the numeric attributes. So sum of the city, for example, if I try to do that, it says that it's a non-numeric data. City is a text. I cannot sum the city. But for example, for the credit from the user table, I can just find the sum of the credit. And one thing we can also do is to for these values, we can have some operations, for example, multiplied by 5, for example. If I run this, it will find the sum of the credit and multiply it by 5. For example, if if we have some monthly values, if we would like to convert them into yearly values, we can maybe multiply with 12 in that case. Or we can divide it by the count of the users, for example. This is going to give us the average credit as well. But for the results of functions, we can do some operations, mathematical operations. And again, this is showing me some weird looking column name, and we can also give a new name to these values as well. Let's write new name. So in this case, this is going to be the attribute name. Any questions, problems about this? Of course, we can mix and match this with other types of conditions. So let me create a new query in SQL. Let's say that we would like to find name, date of birth, and credit of the users who have more credit than the average and was born before 1990. So we would like to select the name, the date of birth, and the credit. Again, we are involved in the same table user, and we have two different conditions. The one condition says that these users should be born before 1990. So this is a condition for date of birth. The date of birth should be less than this date. And we have another condition, so I'm using the AND operator. I want the credit of these users to be higher than the average. So the credit is going to be larger than some value, and for that value I'm going to use some subquery to calculate the average credit. And to calculate it, we need to select the average of the column credit from the user table. So this is my query. From the user table, I project these attributes, and I have two different conditions. One is saying that date of birth should be less than this value. The other is saying that credit should be higher than some result that I obtained from this subquery, and in this subquery I calculate the average credit from the user table, and I also need to include this ending parentheses for the function. Remember, with the functions we have parentheses, and in those parentheses we need to include some parameters, attribute names most of the time. And whenever I run this query, it shows me the results. So these users are here because they satisfy the both conditions. So their date of birth is less than 1990 and they are paid more than the average. And these logical operations, you need to be careful about them in the exam as well. So for example, if I were to write OR here, then I get different results, right? Then they are satisfying either this condition or the other condition. So with AND and OR, you need to be careful. And in the relational algebra as well, if you are using the symbols, so the union and the other symbols, you need to be careful about how you use them. Any questions, problems? Let's make one query before the break. So this time we would like to find name, surname, and company name of the users that are partners of companies. So in such cases, in the design view, what we were doing is that we include multiple tables, and if those tables have some relations in between, it was making the join operation automatically. But in this case, so we would like to get the name, surname, and also the company name. So the question says that find name, surname, and company name of the users that are partners of companies. And if I were to check the user table, in the user table I just store the users. To know the company name, it is included in the company table. And to know which user is a partner of which company, I have the partner of table, which is the relationship in our ER diagram. I need all three tables to write such query. So therefore I need to write from the user table, partner of table, and the company table. If I just run this query, it will make the cross product or the Cartesian product in between these three tables. But I need to specify some condition, right? I need to make the join operations. If I'm writing SQL directly, I need to specify the join conditions, otherwise it is making the cross product. And I will define these join conditions as var statements. So I want to, from the user table, I want the ID to be equal to the primary key in partner of, which is named as user ID. Let me quickly show it in the tools, relationships. So the ID of the user is going to match with the user ID that's inside the partner of table, and for company, CID inside this table is going to match with company ID inside the partner of table. So in here I need to specify these both conditions, saying that and at the same time from the partner of, I want the company ID to be equal to the one that's inside the table company. So in here also, so we made some mistake, column not found, it says. For the company we use the uppercase letter. If we fix that, we are showing the names and surnames of the users, and next to them the company name is included. So notice how we are referring to the attributes. So first the table name, then the dot, and followed by the attribute name. And also be careful that that is not inside the double quotation, otherwise it will give us a problem saying that we cannot find it. But if these attribute names are different, meaning that ID is only included in the user table, and in this relationship partner of, I'm using a slightly different name. In that case, I don't need to specify which table this attribute is coming from, because it's already clear that which table CID is coming from, because among these three tables, CID is only in company, company ID is only in partner of, user ID is only in partner of. So in such cases, we are fine if we don't define the table names as well. Any questions, problems? Otherwise, let's give a 10 minutes break. And let's come back in 10 minutes. Okay, any questions, problems before we start? So one important thing is when we are using SQL queries with multiple tables, if we would like to join those tables, we need to specify the join conditions as var statements. And for example, if we have 3 different tables, so for each link in between those 2 tables, so in between user and partner of, this is my join condition. The ID of the user should be equal to user ID of partner of. And for the link between partner of and company, I want the company ID inside the partner of to be equal to the CID of company. And with these join conditions, we are combining them with the AND operation. Otherwise, it is not meaningful. It will join separate parts, but with the OR operation, they are not at the same time, which defeats the purpose of joining them. And we can also specify additional conditions. For example, I can write, I'm listing the users and the companies there that are, or let me say it like this, I'm showing the name and surname of the users and also the company names that these users are a partner of. And I can also say that, okay, for these users, I want the credit to be larger than some value, for example. Let's also show the credit in this case to check that. And if I run this query, now I only see such users and their companies if those users are having more than 500 credits. And for example, some user could be partner of multiple companies. That's possible in our database, and for those users we see their names multiple times with the different company names. And one thing maybe to show is when we include, for example, 2 tables, for example the user and the company table, and let's say I would like to show the company name from the other table, and from the user table I show the name only. In such queries, without the join conditions and in between these 2 tables, I cannot join them directly. I'm using the separate table called partner of. But if I were to include 2 tables, it is going to make a Cartesian product, meaning that each user is matched with each company. And in the results, we have lots of results actually. We had 20 users and I guess 10 companies. So we get 200 results. For example, Joe is matched with every other company. Luis is matched with every other company. And for each company, it's matched with every other user. And we are using sometimes these Cartesian products to solve some problems as well. For example, in relational algebra, when we try to find the maximum of something, we need to include the same table twice, right? And then we make some comparisons, etc. We can do a similar thing in here as well. For example, let's say that we would like to find the name and credit of the users that live in the same city as a user named Brandon. We can solve this in different ways. But for now, let's try to solve it with Cartesian product. So here, I would like to show the name and credit of the users. And for such users, I want their city to be equal to what Brandon has. If I were to have two instances of the user table. For one of the users, I can find the city of the Brandon, and for the other one, I can check for the equal cities. So I would like to make a Cartesian product using the users. But if I were to include the same table twice without giving different names to them, it's not possible to refer to attributes of one table. Therefore, I need to give names to these tables. For example, let me rename the first instance as U1, and for the second instance, let me rename it as U2. Then I can do this. I can say, okay, for U1, I would like to first find the Brandon. Then I want, for U2, it doesn't matter, but let's do it for U2. For U2, I would like to find Brandon, let's say. Then the name of the U2 side should be equal to the string. So this is going to be text. I know it's, therefore I'm using the single quotations. The name should be Brandon. So this is some username that we have in our table. For U2, I will find this user. And then for U1, I want its city to be equal to this one. So my other condition is saying for U1, the city should be equal to what U2 has. So without the condition here, it will make the Cartesian product. But when we are showing things, let me first also include the table names here, because this time if I leave it like this and try to run it, it actually runs, but to make sure that which table these are coming from, because U1 and U2 has name and credits. It might have been coming from the U2's side as well. In some cases I need to write the name of the U2. If I run it like this, the name is all Brandon. I guess in this case it is using the first instance automatically. But to make sure that it is showing the correct thing, I need to write the table name. So to investigate it better, what I will do is to also include, or let's say instead of the city, let me, instead of the credit, let me show the city for both sides. And the name, this time for U2. And without any condition. So this one, without any conditions, is making a Cartesian product between U1 and U2, and I'm showing city and name for both of these. And when I run it, so William has no city, but for the other ones on this other side we have city information. So my first condition was saying that the name on the U2 side, so on this column, I would like to find Brandon. So in this Cartesian product of every other user matched with every other user, in this U2 column for the name, I want the name to be Brandon. And if I run this query, now every time on this second column side I have Brandon, and on the other parts I have all different users. And this time my other condition is going to be for this city column to be equal to the other city column. So if I run it, now I see the ones that live in the same city as Brandon. And on top of this, I can also say that, okay, I already know Brandon's city. I just want to show the ones that are not Brandon. I can also say that U1's name should be different than, so this is saying not equal to. I can either write U2's name or I can write Brandon directly. So these names should be different. So in that case, let's just project what the question asks. So we would like to find the name and the credit, but on the U1 side only. So if I run it like this, now I see Wayne and Alice. But on the U2 side, I just have Brandon. If I were to project the ones on the U2 side, it will show me the Brandon twice. Any problems, questions about this one?
Can you tell me the meaning of the greater and smaller than the signs?
So this means not equal to. It's like a special symbol in SQL. So in some languages we have exclamation mark followed by equal sign, and in SQL the same is with this sign.
Okay, thank you.
No problem. Any questions, problems? So we solved this with Cartesian product, but actually we can also have a different solution. We can first find the city of Brandon. So from the user table, our condition is going to be for name to be exactly equal to Brandon. With this query, I can find the city of Brandon. And if I were to use it as a subquery, in my main site, I can project what the question is asking. It's the name and the credit from the user table, and my condition for these users is that their city should be equal to what I get from this result set. So this is going to do the same thing. If I run this, now I see such people, and as another condition I can add that this should not be equal to Brandon as well. So this is also one other possible solution. And if this subquery can return multiple things, which is possible if we have multiple Brandons, then writing in here is the better choice. Because if it returns a multiple result set, then with the equals sign we cannot use it, but with the keyword in we can. So let's say that we would like to find number of users from each city, and we would like to also display the city name with these counts. So with a new query, we would like to somehow select the number of users, so we can understand that we need to use count from the user table. So if I were to run such query, it shows me the total number of users. But I would like to find this count for the user groups per city. So users are living in different cities. I would like to first group the users according to the city, and then I want to display the count. In this case, we have the special keyword group by, and next to it I can write any attribute name that I want to group them accordingly. This time I would like to group users according to the city they live in, and I can show the result of a function for each group. So if I'm using group by keyword, it is going to create groups of users or groups of entries. So if I run this query now, it will show me the count of users in each group. But I also would like to display the city name along. So as some other attribute to project, I can include the city. So if I run it, now the first one is for the null value. We have 3 null values. And for the remaining of the cities, these are the number of people that are living in that city. So this is how we do it with group by. And there is some special features of using group by, or let's say rules. Let me also show it in the handout. So we are making the group by operation on a bunch of attributes, let's say. And for that attributes, what we can project is limited. So if I can get these, I will show it quickly, or okay. So let's say that we group our entries according to a bunch of attributes. This can be a list of attributes. There can be multiple attributes here. What we project should be a subset of these attributes too. So let's say I group by the city name, then I can only project the city name plus functions. So returning back to here, what we said is, if I were to also include here, for example, the credit, it will not allow me to do so. It says that not in aggregate function or group. So when I group according to the city, I cannot project according to the credit. That's our rule. If I have to project the credit as well, then I need to include credit as a part of my group by statement. So whenever I run this, now for each city and credit number I'm making groups, but in each group there is only one person. Maybe this grouping is not that meaningful. So with group by you should be careful. Some people mistakenly think that in lots of cases we can use group by, but it's actually very limited. Group by is used whenever we would like to inspect some function in groups of data. If you include lots of things to group by, then you can project lots of things, but then in each group there is only one person, for example, one entry. So for example, also writing the name, maybe you would like to also show the name of those people, but then you need to also group according to the name. Then this defeats our purpose, right? We would like to group users and find the count inside those groups, but then if the name is something that we group by, then in each group there is going to be one entry only. And if I were to interested in showing the cities of each users, I don't need to use group by. I can just do this without the count, and then I can display the names and the cities. So group by is used for inspecting something. So for example, in this case it is meaningful because we are grouping according to the city and showing how many people are coming from that city. Is this clear? Any questions, problems about this? This is actually some point that people could do mistakes in the exam. For example, if you write name here, the teacher will reduce like some points. You need to be careful about it. The things that you project should be a subset of the things that you group by plus the functions. So I can include count here. For example, if I would like to show the minimum, or in this case it's not that meaningful maybe, but let's also so this is going to be in each group the minimum credit for that group. For example, in Istanbul there are 3 users, and among these 3 users the minimum credit is 100, for example, when we are inspecting something among the groups. So with the other question, let's find the number of partner users per company, and we would like to display the results along with the company name. So remember our query when we were trying to show which user is a partner of which company. So we need to use 3 tables, right? The user table, the partner of table, and the company table. And whenever we include multiple tables, we would like to put the join conditions as well. ID from the user table, it should be equal to the user ID in the partner of table, and we have the other condition saying that CID of company it should be equal to the company ID, and like these can be in any order. It doesn't matter which one you make the join first. For example, it can appear like this as well, or these sites could change position as well. So this is our join operation, and we would like to find the number of partner users per company. So in each company there is going to be some multiple users. We would like to display the company name and the number of partners. So we would like to use the group by operation. And with group by operation, for example, let's group them according to the company ID, CID. Then I can project or select CID. This is something I can do. Plus I can display the result of some function, for example the count function. If I run this query now, for each company I will see the company ID and then the number of users that are partner of this company. For example, for company ID number 4, there are 5 members, and I can check it from the partner of table. For company ID 4, this is the first, second, third, fourth, and there should be one more, the 5th one. So there are 5 partners of this company ID 4, and these are those users. This is fine, but the question was saying that display the results along with the company name. So instead of writing the company ID here, I'm just fixing these. Whenever I switch back to other position, it disrupts the indentation. This is okay, but it asks me to show the company names here. And if I run it, now company name is not a part of the things that I group by. Therefore, I cannot project it. One thing I can do is I can group according to the company name. So I don't actually need to specify the table names. It's like whenever I mistakenly switch back to design view, it automatically put these, but I don't need to specify them because each of these attributes are only included once in each table. So this is something I can do. I can group according to the company name, and then I can show the company name and the count of the partners. But there's one problem with this. If, for example, the company name is not unique, in this case it is not unique. For example, I can open the company table, add some CID 11, and for this name I can, for example, write Ocean Arts again. This is some other company, but it is using the same name. And for example, for this new company 11, let's add some new partners. So the user number 1 is a partner of this new company, user number 2 and 3 and 4. So I added 4 partners for this new company. Going back to our query, previously these results for Ocean Arts we have 4 partners, but whenever I run this query again, Ocean Arts seems to have 8 partners. But actually what happened is, if I were to use the CIDs, actually what happened is there is a new company with ID 11, but it is using the same name. So you might assume the company name is unique, and if it is unique, this query works. Otherwise, if I would like to also show the company name and keep these 2 different Ocean Arts different, so these have different CIDs, but they appear as one line since they have the common company name. In such cases, what we can do is we can include the CID as well for the group by statement. We first group by CID and then group name. We group by CID and then the company name. As a result, we can also project the company name this time. And since CID is unique, I can make the group by operation on top of this. And whenever I run this query, for different ocean arcs, I see their results as different entries here. Any questions, problems about this one? So this is actually a good solution without writing lots of things. There is also a separate solution, so it's included in the handout, but let's go quickly over it. So instead of including the CID or company name as a separate group by attribute, we solve this small problem in our subquery. So in this subquery, what we are doing is we just group by CID. These two are our join conditions. So these are the three tables. We make the join operation, we group them according to CID, and we project the CID plus the count, the number of partners per group, and we give the name user count to this. And we use the results of this subquery as a table. So we write as groups. So this result set, we give the name groups to this result set, and this is included as a thing that we list in our from statement. So this could be like more complicated, and I guess in the exam you will not see such things, maybe a simpler one, but in this case we are including the result set similar to a table, and then we can make a join operation in between the company and these groups. But the solution that we do is enough in this case. So we group by according to two attributes, then we can also project this value. So for the groups, we can also have some special conditions. Let's say that we would like to, let me actually get some of this. So with new query, let's say that we would like to find the CID of the groups with more than two partners. So I would like to select the CID. These are my join conditions. And I would like to have one more condition saying that in each group, there should be more than two partners. So let me include the group by. We would like to group according to the CID. And for now, our results are this. So we group each CID, and we just project the group's CID. So we actually show each company. But for each company, actually, there are grouped entities here. And we would like to, for example, we can show the count per group. Then, like we see that for company number 1, there are 2 users. For company number 2, there are 2 users, etc. But this time, we would like to put a limit for what we display. And to do it on the groups, we have the keyword having. So after having, I can write a function. I can write count, for example, and I can say that this should be larger than 2. And whenever I run this query, now it only displays the results when there are more than 2 people in a group, for example. So let's make it more higher. So if I say the count is higher than 4, these are my results, and I don't need to show the count, so I can just show the CID and say that the company with CID 4 and 5, for these ones we have more than 4 partners. So with having, we are inspecting the result of some function. But with where statements, we are looking at separate attributes for individuals. So that's the difference. With where statements, we specify attributes, and for that attributes, we are looking at individuals. With having, we specify functions and we inspect something for the group, for the whole group. And as a result, for having, we are not using the attributes. So for having, we are using the results of functions. So it could be as well something like the minimum of the, for example, credit of the users should be higher than some value. We are only displaying such companies, for example. So in here, we are actually finding which user is a partner of which company, then we are grouping according to CID. And then for these groups, we only show the one who has the minimum credit higher than 300. Or it could be some other function as well. So if we were to check the company number 6, so the partner of table company number 6, we have the user number 10, and that's actually the only user in this company. And if we check the user table, 10 has more than 300 credits, which is the minimum that's in that company. We can also add more conditions. So these are our join conditions. So let me switch back to the count version with number 2 here. So these are the companies. Let me also show the count here. And for individuals, we can add more conditions, right? For example, in here I can write, after the join statements, for each user, I want the individual's credit should be higher than 300, for example. This time we specify this rule for the individuals. Then whenever I run, now we get nothing. So for each user, let's say a less amount of credit. So this is our result. So we can, for example, write average of the credit per group should be higher than some value. Let's say the average should be higher than 500. And for each group, if we are including members with higher number of credits, maybe this was not that good of an example. Let me do it for 400 maybe. Okay, so if the average credit is 400, if I increase this per user limits, then we get more groups, because the groups are formed after we make the var statements. So the first thing that we do is join operations. Then I only select the users that have higher credit than 400, and if I group those users, they will have their average more, right? So if I decrease this, if I'm saying each user I include has at least 100 credits, then I have less groups, because in each group there are, for example, in group 10, in company 10, there are actually 4 people if I consider the credit to be larger than 100, and those are decreasing the average of these groups. But in the case that I only include the rich members, for example, in that case, whenever 400 was a good number there, whenever I look at each group, in each group there are less people, but they satisfy this condition, having the average credit larger than 400. So these are our select queries, and we also have insert, update, and delete queries. And let me show you one basic form here. For example, we can say update the credits of users that live in Ankara or Istanbul by 10. So we write update instead of select, followed by the table name, and then we use the keyword set. So we are going to set some attributes to some values. We can write credit equal to 10, for example. this query will set all users credit to 10. And there is no simple undo button, so be careful when you are working on your projects, etc. And we can also specify some existing columns and the same column name, for example, the credit. This is going to be an increment operation, right? The existing value of the credit, we will add 10 to it and set it as the new value of the credit. And we have some condition saying that the city should be in this set of things. It is going to be Ankara or Istanbul. This is our update query. But remember what I said at the beginning. If we are using this design window, let me copy this, we cannot run insertion, update, delete, and create queries. So it is saying that this is not a select statement. Only select queries are allowed in this part. So therefore, to test or run this query, I should go through Tools and SQL, and I will use this SQL command window to run such queries. So in this window, if I paste it here, now let me first check the user table. These are my credits, 300, 520, etc. And if I run this update query now, it says that command successfully executed and 6 rows updated, because 6 of the people are either in Ankara or Istanbul. And whenever I go back to the user table, this was opened before, therefore I need to refresh the values from the database. If I refresh my values, the ones in Istanbul or Ankara, they have now more credits. So let me, just to show it, for example, Brandon has 390. If I run this query again, command executed. If I come here and refresh, Brandon has now 400 credits. If I don't specify a where condition, then it will do it for all the users. Now if I execute it, it says 20 rows updated. If I come back here and refresh it, everybody has 10 more credits now. And we can have lots of different conditions here. For example, I'm going to this time use this view to write it to make it look larger and then copy and paste it back there. So for example, we can set the status of the users as well. So we can, with this one, set status of the users that were born before 1980 to full. So for example, I can write status is going to be equal to the string, the text full, and my condition is for date of birth to be less than 1980. So for such users, if they satisfy this condition, it is going to update, and I see that 9 rows are updated. If I check back my user table and refresh it, now most of them have the status full. So let's also try to do this following query. It says that increase each user's credit by the monthly payment of the companies that this user is a partner of. So we have a bunch of users, they are partners of some companies, and for each company, for example, one user is going to be the partner of multiple companies, and those companies have monthly payments. We would like to increase this user's monthly payment, this user's credit by the sum of monthly payments of the companies. So actually what we would like to do is to update the user table. We would like to set the credit amount to some value. Actually, we would like to increase it by some value. So it is going to be credit plus something. And for that something, we would like to calculate it with a subquery. So if I were to look at the monthly payments of each users in my subquery, I can write something. So select the monthly payment, let's say. So in the company table, for each company, there is some monthly payment. And to find which user is going to get this monthly payment, we need to join the user table using the partner of table, and also we need the company table. And remember our join conditions for UID to be, it was ID. We want ID to be equal to user ID, and the other condition is for CID of the company to be equal to company ID that's inside the partner of table. So these are our join conditions, and with these join operations we can find the monthly payment, right? But this time, instead of including a separate user here, I would like to use the same user that's outside my subquery. So this is my subquery. I include the user table to find the monthly payment, but instead of using a different user table, if I don't include the user here again, then this ID will correspond to the ID of the user that's outside my subquery. In such case, I find the monthly payment of this user, and then I can add it on top of the credit. But there is one more thing, that this user could be the partner of multiple companies. So in that case, this will return more than one value. Then I would like to increase the credit by the sum of monthly payments. So I need to find the sum of monthly payments. So this is my basic query with the join operations. But instead of introducing a new user table, I'm using this user for this user that's outside my subquery. I make the join operations, find the monthly payments, but it can be more than one monthly payment because this user could be the partner of multiple companies. Therefore, I need to sum these monthly payments, and with this sum I can add it on top of my credit value. So whenever we look at this, this can be told as this. So indentation is for us to see it better only, otherwise the program does not care about this indentation. So I'm increasing the credits by the value of this thing, and this subquery finds me the sum of monthly payments this user is a partner of. And if I come back to my execute SQL statement window, I will paste this here and execute it. I see that 20 rows are updated. For each user we made an update, and whenever we refresh this user table, we see that their credits are increased. So each time we run this statement, we update each user's credits by the monthly payments or sum of the monthly payments that this user is a partner of. Any questions, problems about this one? So with update queries, we are setting some attribute to something else, and that something else could depend on existing attributes, and we can again use some operations, use some functions to find the results. And additionally, we can have lots of different where conditions as we did in the select statements. So in here for an update query, we can list lots of different conditions. Then we have delete queries, and again with deletion, whenever you are working on the project, you should be careful because you can, like let's say you add lots of entries, and whenever you delete, there is no simple undo option. So our format starts like delete from this time, and then we write the table name followed by our conditions. And these conditions are again similar to what we have in select queries. And whenever we run such query, it is going to delete those users. So let me just copy this one to show it running. So I will paste it here and execute it. And I see that 7 rows are updated. 7 people were getting more than 100 credits. And whenever I refresh this table, now those 7 people are gone. Since we, in the relationships view, since we wrote update and delete cascade, whenever we lose this user, they are also removed from this partner of table. Again, we can mix and match different conditions. We also have the insertion queries, and the form is like this: insert into followed by the table name. For each table we have a bunch of columns, and these columns are in some order, right? If I check my user table, for example, these columns are in some specific order: first ID, then name, then surname. And whenever we are inserting some new data with an insert query, it expects the values in order. So for example, if I would like to add such user, the name is John, credit is 100, etc., I need to write these values in the order that's in the table. So first the ID, then the name, then the surname, etc. And remember, with numbers we write them directly, but with text we need to include single quotations, and with date as well we include the single quotations plus the special form of writing year dash month dash day. So if I run this query, it will insert the new user. So again, since this is an insertion query, I need to execute SQL statements. I need to use this window. I will execute it. It says 1 row is updated. And if I check my user table, not here, I will see that this new entry is now here. One thing, if I try to execute it again, it will give me an error because I'm trying to insert a user with ID 21, but there is already an user with such ID. So it says that violation of unique constraint. It will create duplicate values for the ID column. So whenever I want to run it again, I need to change the ID. So for example, if I change the ID into 22, and if I refresh it, now I have the same values, but this time for a different entry. If I would like to give the attributes in a different order, what I need to do is, after inserting to user, so this is the same part, I give the names of the attributes in some different order. And then while I'm giving the values, these should map correctly. So the name is John, ID is 21. But these are not following the regular order of the table. I am defining a different ordering. And with this form of notation, what we can do also is we can leave some columns empty. For example, this is also possible. We are writing insert into user, name, ID, surname, and date of birth. These are the 4 things that I'm going to give you. And these values are John, 21, Doe, and this date of birth. And then whenever we insert using this notation, the remaining attributes will be empty. So let me run it with ID 23. So if I execute it, it says 1 row is updated. If I check my user table and refresh it, I see John Doe, this new one is added, but the columns that I have not written are empty. With this notation, one thing to be careful about is that I need to write the required ones. So for example, if I try to omit ID here and 23 here, it is the primary key. As it's the primary key, I have to write it. And if I try to execute it as it is, now it says that attempt to insert null into a non-nullable column. For ID, I cannot insert null values. It cannot be left empty. Therefore, I need to specify something. So for now, we are running our queries. For selection queries, we can save them in here. So whenever I create query in SQL view, for select queries, I can save them. But for other types of queries, for insertion, deletion, update, I need to test them in this view. But then in the upcoming labs, we are going to create forms. So in forms, we are creating some windows for the user to operate on our database. For example, we will create text boxes, we will add some buttons, and for example, the user is going to type some value in here and click on the button. Maybe this is going to be the value that we would like to increment the credits by. So for example, user writes 10 here, clicks on this button, and whenever we click on that button, we are going to run some update query, etc. So this is going to happen in the upcoming labs, but in lab 4 we are going to see some more complicated queries that might help you in the project. But for the exam, I guess this much complexity is enough for the exam, but for projects sometimes you need to do a little more complicated queries. If you don't have any questions, that's it for today. Any problems, questions? So see you later then.